quite possible that the haplorhines emerged in Asia. So the first haplorhines come from China, possibly. This is reinforced by some later developments called Eosimias, which means dawn monkey, Eosimias, also found in China from about 42 million years ago. And Eosimias is what we call the basal anthropoids. And so this is the development away from things like lorises, lemurs, and tarsiers, which have that bone, that talus bone, that we've got in our feet, but it's a heel. And for like a tarsier, it's like a spring, like a frog leg, so they can leap. Now, at some point that we've got to lose that, or our ancestors have to lose that to develop into a heel for grasping feet that most other anthropoids have. And so you see this starting to develop in China at about 42 million years ago with Eosimias, and their teeth are also very anthropoid-like, and they have a shorter heel. So these are some of the things that we start to see developing into anthropoids. And so it looks like anthropoids in general emerged in Asia first. But our evidence for the environment and how far these forests spread is piecemeal, but we then start to see, so that's 42 million years ago in China, that's the earliest evidence that we have, but by about 37 million years ago, we see Beretia in Egypt, which is also a basal anthropoid. And so it's possible that it may have anthropoids, which means human form, or anthropoid means human-like. So that's our group, emerged in China first, maybe spread over or maybe migrated over to Egypt, which is in Africa, of course, about 37 million years ago. So it's looking like that is the origin of anthropoids. There's a summary at the end of this chapter as well on these things, so to clarify these. Now, we get into the Oligocene, which is from about 34 million years ago to about 23 million years ago, and this was a period of global cooling where new habitats started to emerge. And one of these places that was a real lush, swampy area was what's called the Fayum. Today it is a bleak, desertic area in Egypt, it's been worn away, but it is one of the first of these so-called hot spots that I talked about last chapter. It's a place where we've recovered a lot of fossils for this time period. So the Oligocene environment and the sequence of changes in primate biology can be seen all in one spot, changing through time in all of these strata. So the Fayum Basin has exposed really terrific information and for the evolution of early anthropoids. And in this Fayum, we see some of the earliest Oligocene primates in the Fayum are in this tropical, what was once a tropical, swampy, forested area. We see the Oligopithecids, which are from about 35 million years ago, and they are some of the oldest absolutely identified anthropoids. So although the origin of anthropoids may find a little bit earlier in China, the first and earliest clearly defined anthropoids can be found here from about 35 million years ago in the Fayum Basin in Egypt. Now, these slightly later than the Oligopithecids, you get what are called the Parapithecids. Now, if we recall earlier discussions about dental formulae, where we have 2, 1, 2, 3, that is to say 2 incisors, 1 canine, 2 premolars, and 3 molars, that's us. And that is not what you find in the New World monkeys, species of monkeys. The New World monkeys have 2, 1, 3, 3 almost entirely, although there's some differences there. And these are the platyrrhines. We're not platyrrhines, we are catarrhines. But you find in the Fayum Basin the Parapithecids, which have the dental formula 2133, which is what you get with the Platyrrhenes. And so this may very well be the origin point of the Platyrrhenes that somehow got to North and South and Central America. If you look at a map of what the continents, where the continents were at this time, there was a gap, a separation between Africa and America, and so they couldn't have just walked there. But it is possible, it was close enough that rafting on mats of vegetation or something could have taken place, and that's really where we presume happened, is that some Parapithecids that emerged in Africa found their way to South America, became geographically isolated, and went off in a different direction, and that's where you have the Platyrrhenes and the Catarrhenes starting to emerge as different groups. And then you also have the group of, in the same sequence, slightly later, you have the Propleopithecus, which is a group of primates, one of which you've already been introduced to, and that is the Aegyptopithecus. And this is the one that I talked about before that has very monkey-like features in its body, but its cranium, its head, is very ape-like. And so this is seems to be where the Catarrhenes are splitting, and that is the group that we're most interested in. So Aegyptopithecus is an arboreal quadruped, but it's sort of a monkey and an ape ancestor. It's one of these transitions. It's a snapshot. Also from Saudi Arabia, there's evidence from about 28 million years ago of Sa'adanius, which is larger than Aegyptopithecus, and it seems to have preceded the split between the old world monkeys and apes. And so it might be the ancestor to the Catarrhenes. And it pushes the date of the last common ancestor between old world monkeys and apes to about 28 million years ago. I'll just instruct you to take a look at the maps on the placement of the Platyrrhenes and the Catarrhenes on the continents as they were at this time, and you'll see how close they are together. They're separated by a small body of water between Africa and South America, but they might have been able to get there. And the slide that's on Canvas explains a little bit in the text on that slide what the various hypotheses are. The most plausible scenario that we imagine based on the evidence is that there was rafting that occurred from Africa to South America directly, rather than alternatively a separate group being emerging in North America entirely unrelated to African primates. That seems unlikely, especially with DNA. Also, hopping over to Antarctica doesn't seem likely, and two completely separate species of primates emerging on different continents is very unlikely. So it really does seem like what we find in Africa in the Oligocene is the origin of this split between the Platyrrhenes and the Catarrhenes. The Platyrrhenes floated over and became isolated in South America, and that was the form that survived there, whereas the Catarrhenes survived and developed in the Old World, Asia and Africa. So I talked already a little bit about the Platyrrhenes, so I won't go back to that, but at the beginning of the Miocene period, the planet again began to warm, and this created new and expanding forests for the Catarrhenes. And about 23 million years ago, Catarrhenes started to diverge into two lineages. Those are the hominoids, those are apes, and the Cercopithecids, which are old world monkeys. And so the monkeys are the Cercopithecids, and the hominoids are apes. And we are in the hominoid group. And so we'll focus on that part of the lineage. And the earliest of these hominoids, the apes, are called the proconsolids. That word, incidentally, in Latin means governor. So the governor ape. And we see some of these features that we share. So they've got honing canines, which we don't have, but we lost those. We'll look at the fossil evidence for that later. They're fruit eating. They have Y5 molars, which is something that we do still have. And they have no tail, which we also do not have. And they started to emerge about 23 million years ago to about 17 million years ago. You see the proconsolids starting to emerge in eastern Africa. The proconsolids were sort of monkey-like from the neck down. They had equally length limbs, so they probably crawled along the tops of trees rather than always brachiating, but they also did have the ability to grab and swing beneath the branches as well, and that's evidence in fairly long fingers. They don't have as much mobility in the wrist, shoulder, or elbow as what is found in modern apes, but more so than you find in monkeys. Their arms were relatively shorter than their legs, though, and so and their rib cage was deep like a monkey's rib cage. So modern apes have really big hands, long arms, and a shallow but wide rib cage. So it's an ancestral ape from the Miocene, but the ape-like body seems to have emerged a little bit later in the Miocene. So this early form of proconsolid body plan doesn't seem to have been really adapting the body, more some of the features in the face. So larger brain, different types of teeth, eating things like fruit. You have other primates emerging in different parts of the world. We've been talking about Africa. That's where one of the hotspots is in the Fayum. That's really helpful to us. But in the middle Miocene as well, you find things like the Dryopithecids in Europe, in Spain, France, Germany, Greece, Hungary, and Turkey. And these Dryopithecids had large honing canines and a Y5 pattern on their molar teeth as well. And so they're a little bit later. It seems like you've got the spread of some of these apes out of Africa and into other parts of the Old World. Oreopithecus was found in modern-day Tuscany and highly suspensory, and so seems like they were developing some of these abilities to grasp tree branches. And also, Dryopithecids and Oreopithecids had larger brains than proconsolids. And so you see some of these developments starting to emerge as different adaptations in different places. In Asia, you have the Sivapithecus, which was a group of primates, apes, I should say, that were found mostly in places like India and Pakistan, and although some found in Turkey as well. These Sivapithecids had very, very thick enamel, which was used for eating hard objects like nuts and seeds. And in fact, although the picture that you see in the slide makes them look a little bit like an orangutan, apparently they're not very closely related to orangutans, and they were much more like proconsolids in their body types. The one group of this Asian type of ape actually grew to huge size. It's called Gigantopithecus. And they're only known through jaws and teeth. We don't know a lot about them, but they were absolutely enormous and would have weighed up to about 500 pounds on entirely a diet of bamboo. And so they actually lived until fairly recently, and maybe even overlapped in time with Homo erectus, one of our most recent ancestors, human ancestors in Asia. So that's all I want to say. There's some slides that actually sort of summarize this development of the origins of primates, the development of certain types in China that then maybe moved throughout the forests into Africa. We have a split of the Platyrrhines and the Catarrhines. The Platyrrhines going to the New World, that is North and South America, Central America, and the Catarrhines staying in Africa and Asia and developing there. From those Catarrhines, we have the hominoids start to emerge, the apes, and we count ourselves amongst that group. And although the earliest evidence for apes emerges in Africa, we see them fairly quickly spreading out into the rest of the Old World. And so we'll pick this up again in the next chapter, when we'll start looking at the development of the species more closely related to us. I'll see you then.